Well, hello, everyone. Welcome back. I'm Paul Deffenbaugh, the editorial director at Modern Trade Communications. For those of you who joined us last Thursday, my apologies for our audio problems. The increase in remote workings overloaded the circuits, and we've been assured that everything is okay now, but we're living in uncertain times right now. So if we do run into the same kind of audio problems, here's what I'd like to do. I'm going to end the webinar for everybody, and then 5 minutes after the end of the webinar, I'll start it back up again. That way everybody knows what to do. You'll have to log back in. I apologize for that inconvenience, but it seems like the best way for us to start. Today, we're offering the Single Skin Metal Siding Performance and Design Considerations webinar presented by AEP Span. It's part of our series of webinars at Metal Architecture Magazine, and we're glad you've joined us. I'm going to turn things over to Tyler Murray here in a moment. He's today's speaker, but before we start, a couple of things. The webinar is going to last an hour. Tyler's going to take questions throughout the presentation, so if you have a question, enter it on your panel there. I'm going to be monitoring them, and I'll jump in to ask the question for Tyler at a moment that's appropriate. A lot of you are going to want to know how the CEUs and certificates will be handled. If you've entered your AIA number during registration, you don't need to do anything else. It'll automatically be taken care of. And tomorrow at 1 o'clock Eastern time, everybody's going to receive an email that will have information on getting a certificate and an email link to how to view this presentation again and more information. That's 1 o'clock tomorrow. You'll get that email Eastern time. So now let me turn things over to Tyler. Tyler Murray is a technical service representative for AEP Span. He oversees the weather tightness warranty program in the greater Pacific Northwest. He's been in the construction industry for 20 years with concentration in roofing, installation, and inspection. Tyler's got many certificates in his field, as well as a deep understanding of the products associated with the roofing industry. He also holds the OSHA 510 outreach training card. Tyler's experience in the industry has included roles such as journey level roofer, estimator, and project manager. Prior to working with AEP Span, he worked as the lead technical representative in the Northwest for a worldwide roofing products manufacturer. He was responsible for the job site inspection, final roof inspections, warranty claim investigations, and product training for installers, as well as technical training for other technical representatives throughout the U.S. If it sounds like he was traveling a lot, I think he was. Tyler, are you ready to go?
I am indeed. Thank you, Paul. Good morning, everybody. Thanks for joining us again. Sorry about the trouble that we had last week. I'm sure everybody can understand. I'm going to jump right into this thing. The first few slides are information only. I'm just going to get started. Hope everyone enjoys the webinar. There we go. So some of the information on the AIA, the continuing education provider, copyright laws and such. Course description: single skin metal wall siding is a great example of continued advancement of building products in the architectural market that's driven by a more sophisticated design and greater emphasis on sustainable building practices. This course will explore the different types of single skin metal siding, specification details, as well as performance and design considerations. The topics will include material inputs, performance attributes, environmental impacts, and sustainability. These topics are key aspects of today's modernized single skin metal siding. At the end of this learning objective, everyone should be able to understand material inputs and the attributes for architectural single skin metal siding. We should learn about the environmental impact, understand the types of single skin metal siding, and then learn about the design and installation considerations. Single skin metal siding is made up of several inputs, and each material performs a specific function. We are going to start at the base of the metal panel and work our way through the layers of coatings used on single skin metal panels. The base of the metal panel is made either of steel or aluminum, and both offer long-lasting performance. Steel panels are offered in a range of gauges or thicknesses, starting from 18 gauge being the heavy gauge to 29 gauge being the light gauge. The industry standard thickness for aluminum panels are generally offered in 050, 040, and 032. At the end of its life use, the metal siding panels are 100% recyclable, which is good in this day and age. Coatings do not interfere with the panels being recycled. After the metallic coating, there's a pre-treatment coating which allows the paint to adhere to the metal or aluminum substrate. The primer coat allows for further adhesion of the cool top coat or paint finish. The cool top coat color is the last, that not only contributes to the design, but it also has important energy effects attributes, which we'll cover in a few slides. The bottom layer is a backer coat, which is an inexpensive polyester paint system used to protect the backside of the panels during the installation and when they are stacked together for shipment, which helps prevent road abrasion. The clear coat offers a sheen that enhances natural characteristics of the metal, offers bare steel, a bare steel aesthetic design. It resists scuff marks and fingerprints, allowing you to maintain a consistent satin smooth finish through delivery and installation. It offers energy efficient attributes and can also be painted over without primer. There are three major paint types or polymer technologies used for steel coatings. This is a simple visual of the order of the three paint systems from a performance perspective. Polyester paint system is the least expensive paint system used for gutters and downspouts, residential trim, and as a backer coat for metal siding panels and metal coil. By using polyester paint coat on the back of the metal panels and metal coil, it prevents transit abrasion to the top coat finish during shipping and to the backside during installation. An S&P paint system offers better resistance to color, chalk, and fade compared to a polyester paint system and is a versatile paint system. It's used primarily for commercial projects. It comes in a wide range of cool colors with energy-efficient attributes. An S&P paint system offers better chalk and fade resistance compared to a polyester paint system. It's less expensive than PVDF coatings, typically provided with film integrity, chalk, and fade warranty. Has longer film integrity, chalk and fade warranty than a polyester paint system, typically used on lighter gauge metal siding panels for commercial and residential applications. A PVDF paint system is a premium system that provides outstanding resistance to the ultraviolet radiation with exceptional color retention, resistance to chalking, and chemical degradation. It's used on high-end architectural projects or in aggressive environments. This paint is often referred to as Kynar 500 or Hylar 5000. Comes in a wide variety of cool colors with energy-efficient attributes, bright and rich colors with clear top coat to ensure long life performance. Typically the longest film integrity, chalk and fade warranty, typically used on educational, public, government, healthcare, and commercial projects. A PVDF marine paint system is also available for severe corrosive or saltwater environments. There are two PVDF marine paint system warranty options. The first option is a 15-year limited warranty with a high build primer applied under the top coat. Under the top coat, color code is required. A 20-year limited warranty with high build primer applied under the top coat, color coat, and a clear coat are required. The PVDF marine paint system comes with a wide range of cool colors with energy efficient attributes, applied on aluminum zinc coated steel substrate or aluminum. You may have noticed that we have used the term cool colors, and you may have heard the term cool roofs. The same paint systems used on metal roofs are used on metal siding panels. Let's look at this first bullet point. Solar radiation reaches the Earth's surface in 3 distinct wavelengths. It's the IR radiation that generates the heat on the surface. The pigments in the paint system have been altered with special IR reflective pigments that stay cooler than traditional pigments. So when the IR radiation wavelength hits the surface of the siding, the paint system allows for solar reflectance and thermal emittance and contributes to keeping the building cool, conserving energy and saving money on energy costs. The visual demonstrates this point. Uh-oh. Skipped the thing there. Sorry about that. Paint coatings and light reflectance value, which is referred to often as LRV. The light reflectance is the visible light reflected by a surface. The LRV is measured for the amount of visible or unstable light that reflects from a surface. The higher the number, the more visible the light that is reflected. A visual example is when a glare is reflected from the surface. Typically, the lighter colors will have higher value than dark colors, but texture can impact LRV as well. A manufacturer should be able to provide the LRV for a specific color. Note, while there is some overlap between LRV and solar reflectance value, SRV, as many coated surfaces may have a similar LRV and SRV values, they are not the same measurement. SRV measures the amount of total solar radiation, infrared and ultraviolet, that is reflected from the surface. The SRV measurement is exposed as a percentage from 1 to 100. The higher number, the more solar reflected radiation that is reflected. The higher the SRV value, the cooler the surface stays when in direct sunlight. So moving on to objective 2.
Tyler, if you don't mind, I'm going to jump in and ask you a couple of questions from folks here.
Okay, perfect.
A couple of things. One, how do you get a 40-year warranty? What's involved in that?
A 40-year warranty, it's actually fairly new to us. It's a paint and substrate warranty, and all of our products actually qualify for that. If it qualifies for a normal paint warranty, if it's not within 1,000 feet of the coastline or a high build primer project, it's the same as our typical 25-year substrate warranty. Paint
Thank you. Another question here: Are all the paint systems listed in the presentation typical for metal applications, and are all of them considered to have a cool rating?
They are, and they do. Some cool ratings are high, or some reflectance values are higher than others. So different paint colors reflect heat and light differently. So you get a different rating for most of the colors, but all of the colors that we offer are considered cool paint colors.
And a final question: listeners asking, you mentioned the PVDF, the regular one, and the PVDF, the marine version. What's the cost difference in that? What's the kind of percentage increase?
I don't have any idea. I'm sorry. I don't do any numbers. Yeah, but the person who asked that question can, absolutely put a call into their local salesman, and they can get that question answered for them for sure.
Great. Thanks, Tyler.
You're welcome. So, learning objective 2, we begin this objective by highlighting the research on cool sidings conducted by the Lawrence Berkeley National Lab, referred to as LBNL, which is the nation's scientific research lab for the U.S. Department of Energy. They explored cool siding benefits, technology, and infrastructure in a research project sponsored by the California Energy Commission's Electric Program Investment Charge. There's a high level of overview from that research. They evaluated the annual energy cost and emission savings in all of California's climates and U.S. climate zones 1 through 4 from 2015 to 2018. They use the program to model energy consumption for a variety of project types, such as multifamily, various office buildings, and hotels. The findings from the research indicate that cool siding saves energy, money, and carbon dioxide in warm climates, mitigates urban heat islands, tends to stay clean, and cool coatings on metal sidings products are available today, often at no extra cost. The LBNL seeks to expand and enhance the cool siding provisions found in U.S. codes or standards and in green building programs. Today, cool sidings are currently found in U.S. codes and standards and green building programs. The LBNL is developing new cool siding measures and codes and standards and green building programs. They're working on establishing a cool siding product rating system and modeling on or expanding the existing programs. The Cool Roof Rating Council is also proposing to create a rating program for exterior siding products similar to the roofing program, so we will continue to monitor that progress. Today, single-skin metal siding panels contribute to green designs and certification programs. From a green building certification standpoint, we've conducted a comprehensive assessment of LEED V41 to determine how metal roof and siding products could contribute to green certification programs. Although this assessment is based on US GBC's LEED V41 point system, several of the categories in LEED are similar to other green building certification programs, like Green Globe, CHPS, which is a collaborative for high-performance schools. Depending on the design of your project, metal siding panels can contribute to green designs and certification programs. For the Living Building Challenge, building products fit into the materials pedal, red list off the Living Building Challenge. To be eligible, a manufacturer has to disclose 100% ingredients to 100 parts per million of materials and chemicals on the red list. Today, metal siding panels can meet LBC red list free criteria. Metal siding panels coated in zinc aluminum, also referred to as galvium, with a clear protective resin coating meet the LBC red list free criteria. It can be ordered as a standard offer at no extra cost, offers a natural steel aesthetic design, and they're available in multiple profiles. Metal siding panels with cool painted coating also meet the LBC red list free criteria. Typically, a special order with minimum order requirements and offered at a higher price. There are challenges with painted metal siding panels. There's hesitation by coating manufacturers to provide proprietary information on paint formulas. Standard corrosion-resistant primers contain low levels of chrome. Factory-applied paint often contain a curing chemical that while on the red list is reacted and eliminated during the curing process. Despite the presence of a few red list substances, pre-painted metal is inherently safe and does not pose a risk. The industry has been working through this concern, and there have been some performance trade-offs, which until recently was significant. There is progress, and we are actively pursuing a suitable replacement for that. So learning objective 3.
A good time to jump in and ask a couple of questions if you're okay.
Yeah, absolutely. I was counting on it.
We've got a current, with the current LEED 4.1 model, can metal siding contribute more points than were eligible in the previous LEED versions?
I don't know the answer to that question.
Yeah.
One would assume so, but if that person would like to send an email after the asking me that, I can absolutely research it and get you an answer on it.
Great. And then another listener is asking, whatever finishes are specified on the roofing and siding, is that also available for gutters and downspouts and other accessories?
In some instances, yes. It depends on the gutter or downspout manufacturer, but our all metal manufacturers or pre-painted metal manufacturers offer a flat sheet offer, and typically speaking, those products the flat sheet gets made into gutters and trims.
Okay.
So the answer to your question is yes.
All right. Thanks, Tyler.
Yeah, absolutely. Moving on. Objective 3. Objective 3 focuses on metal siding types and specification considerations. There are 2 types of metal siding: exposed fastened and concealed fastened siding panels. Exposed fastened siding relies on visible fasteners to secure the material onto the structure. Concealed fastening siding has no visible attachment points. This type of siding can include direct attachment or clip attachment of the siding to the structure. Exposed fastening siding relies on visible fastening device to secure the material to the structure. Standard or common gauges for exposed fastened metal siding panels tend to use thicker material to accommodate requirements for positive loading only or areas near heavy human interaction. Steel 29 gauge through 22 gauge are industry standard gauges. A corrugated profile should be produced from industry standard aluminum thicknesses of, again, 050, 040, or 030. The profile typically drives the thickness of aluminum that is used. Exposed fastener profiles are offered in a range of ribbed profiles in light and heavy gauges. Here's some photo samples of some exposed fastener profiles. It's very common to see exposed fastener profiles on the outside of commercial buildings. More photos. So for our concealed fasten panels, they provide their own unique look and texture when selected as a siding. Concealed fasten siding provides clean lines by eliminating the need for exposed fasteners and are often chosen over exposed fastener panels where weather tightness is a concern. Panels that can include direct attachment or clip attachment of the siding to the structure. In steel, it's offered in 24 gauge and 22 gauge. Those are industry standard. Concealed attached profiles can be produced from the industry standard aluminum thicknesses, again, 050, 040, and 030. And again, the profile drives the thickness of the panel. So a few photo examples of the concealed fastened siding. So now we're going to learn a little bit about expansion and contraction. Environmental factors driven primarily by temperature fluctuations cause panel assemblies to expand and contract. For steel panels, 1/8 of an inch of expansion or contraction per 10 feet of panel is a common rule. For aluminum panels, thermal movement is almost twice the rate of metal, making upwards of 1/4 inch per 10 feet of panel length. Most concealed fastener assemblies allow for thermal expansion through the use of single-piece clips that slide within that panel seam. Exposed fastener profiles do not accommodate for thermal movement. The fastener mounting hole may stretch or tear, ultimately resulting in leaks. For the right applications, there are many benefits to exposed fastener profiles. It offers a classic design. It's offered in a large range of finishes and textures. The ease of installation. It's easier to repair and replace. This makes them a practical option in high traffic areas where panels could be more prone to damage. With proper sealant placement, exposed fastener panels can provide adequate air and water infiltration control and may have been tested and approved through the ASTM method E283 air and E331 water. Lap configurations. There are 3 main lap types utilized in metal siding panels. The first is a traditional side lap where one panel rests over the adjacent panel. This lap is most commonly found in exposed fastener siding. Field applied lap sealant is required to keep the side laps watertight. The second lap condition is called an integral seam. An integral seam utilizes a male and female lap engagement. The panel attachment is achieved by directly fastening through a nailer strip on the female leg. The male leg is then interlocked, concealing the attachment points. Some integral seam panels offer clip attachment as well for higher wind load resistance. An integral seam panel, they're typically offered with factory sealant in the female leg, or the sealant can be field applied. The third lap condition is referred to as a hook seam lap. The hook seam utilizes two reverse rolled hems that positively engage each other. The panel attachment is achieved by direct fastening through a nailer strip on the mounting flange of the panel, or with a clip that is attached to the substrate. The other side of the panel has a leg or a hook that is interlocked, which conceals the attachment points. Some integral seam panels offer clip attachment as well and are available with factory or field applied sealant. Each option offers the designer a choice depending on the project's structural and aesthetic needs. Integral hook and seam panels generally have substantially higher structural performance when used with clips. They also offer better weather tightness than exposed fastener panels due to their concealed attachment, and may have been tested and improved through ESTM, again, E283 and E331. Hook and seam panels are generally preferred for the most visually demanding and architectural applications and are easy to install. The one-piece clips used with hook seam panels are often simple in design and provide unlimited thermal movement because panels expand and contract within the clip. Learning objective 4. I'll take a breath here in case any more questions have popped up.
Thanks, Tyler. I do have a couple of questions, and I'm going back to look at something so I make sure I get it correct.
Okay.
You mentioned for steel panels an 1/8 of an inch expansion contraction for 10-foot panel length is kind of the common rule. And one of our listeners is there a temperature spread, like 100-degree temperature spread, or like in Chicago, 130-degree temperature spread that would change that?
No, it's really tough, right? And I get this question a lot. It's because I do these inspections, and part of that inspection process is sometimes inspecting the amount of room that they leave for thermal expansion and contraction. When an engineer looks at this paperwork and comes up with those numbers as far as panel length and what to use as far as allowances for thermal expansion and contraction, they do take geography into account, but it doesn't play a huge role in that. That 1/8 of an inch per 10 is worst case scenario. So that general rule of thumb is going to be the most that you'll ever see. Now, given in some places it may be a little bit more than that, but it's not enough of a change to change the amount depending on where you are in the country or where as far as temperature fluctuation is concerned.
One of our other listeners noticed that there were a couple of slides there that showed standing seam panels in a wall application. Is that something that's common? Is it easy to do or hard to do? Or
it is common. It depends on the panel. If you're using a mechanically seamed panel, it's a little bit tougher, obviously, because the mechanically seamed panel on a wall application, requires that mechanical seamer, which is an electric machine, and it rolls along the length of that panel and seams that panel together. So it's a little bit tough. They do have the seaming companies do have that ability, and it can be done. It's a bit arduous, as you can imagine, but I have seen it done. I have inspected some wall systems that have utilized that system. A snap together roofing panel would be a lot easier to make that happen, and I've also seen that as well. So yes, it does happen. It's not super common, but depending on the look that an architect is trying to achieve, it does happen.
I got another question for you. Can the manufacturer specify the fastening requirements for hurricane loading? I don't think you get a lot of hurricanes in the Pacific Northwest, so.
We don't know, but it, depending on geographically, where you're at in the country, and if you have an engineer do those calculations, I believe the answer to that question is yes. I don't know that I've ever heard the term hurricane loading before, though. Yeah. So I'm not super familiar with what that is.
And another person wants to kind of go back to a warranty question here. Of the four main components that make up the outside wall, you've got the air water barrier, attachment system, insulation, and the panels. How does a manufacturer of the panels offer a weather-tight warranty when it can't control the other three elements? Or can you?
Well, in a roof instance, obviously our metal is the last thing, and with every roofing panel, roofing application that you get, we offer a side seam warranty so that guards against leaks in that seam itself. Now, if there's a leak in a wall and it's deemed to be at a component like at a light fixture or coming in at a window seal, and so then it's a point of arguing on to whether it's that metal panel that's leaking or if it's the window seal. So a lot of times it's up to a weatherproofing professional to decide that, but we do not warrant the system as a whole, only the steel.
All right, and primarily that only for leakage, you're not going to warrant against condensation issues or anything like that might build up because of poor installation.
That's correct, and that can be determined very easily.
Great, thank you. Those are all the questions we have for now.
Okay, moving on. Objective 4 focuses on the design and installation considerations. I think I said that already. Single skin metal siding panels have the ability to be installed vertically or horizontally, or a combination of both vertical and horizontal, which offers beautiful design options. Vertical applications offer the installer the flexibility in installation by allowing the panels to be installed left to right or right to left. In a horizontal application, it's a bit different. When installing integral seam panels, they are intended to be installed from the top of an elevation down due to its seam configuration. If integral seam panels are installed from the bottom up, the female leg can trap runoff from rain, which can compromise the weather tightness over time. Traditional side lap seams and hook seams are just the opposite of integral seam panels. Traditional side lap and hook seam panels are required to be installed from the bottom of an elevation up, which allow for runoff to flow over the lap. Installing from top down can compromise the weather tightness over time due to the exposed seams. It's important to take these details into consideration when selecting an appropriate product for a specific application and for phasing of the installation. Metal siding substrates. Installed on a wide variety of substrates, including but not limited to dimensional lumber, plywood, OSB, C or Z purlins, which are steel, hat channel or furring, which is also steel, steel deck, hot rolled structural steel, and lastly, concrete or masonry. When specifying fasteners that hold the panel or panel clip to the substrate, it's a critical component of a properly designed panel assembly. Fastener size is generally defined by the panel, clip fastener clearances, and the substrate being utilized. The manufacturer will include the approved fastener size based on the panel in their approval report, in their installation guide, or by contacting the panel manufacturer's representative. It is the underlying substrate type and thickness that determines the fastener length, point, and thread type. The fastener should be obtained through the panel manufacturer when possible to ensure that the appropriate fastener is being used so the overall panel assembly capacities can be met. There are several key certification bodies who issue product approval reports. IAPMO is the evaluation reports. ICC-ES is the evaluation service reports. Intertech is the research reports, and UL are the evaluation reports. The process in the evaluation is as follows. Starts with the certification body who develops evaluation criteria. They have a document which defines requirements for the products to meet code provisions and for conditions where codes do not address the necessary requirements. Next, the manufacturer seeking the approval report submits all independent test data, performance calculations, etc., as required by evaluation criteria. The certification body evaluates the manufacturer's performance data against those requirements stated within the evaluation criteria. If and when it's approved, the certification body publishes the product approval report. IAPMO is currently the only known certification body that has an evaluation criteria for metal siding. Metal siding and roof panels are prescriptively defined within the building codes and generally do not require a product approval report. However, manufacturers who have approval reports available make them significantly easier to work with, as all the published performance data has been thoroughly evaluated by accredited certification bodies. This is what an evaluation report looks like. The certain metal manufacturers will have these available to the general public on their website. Positive inward loading cables based on gauge and span. And then they do have the negative outward loading based on gauge substrate, fastener, and fastener spacing. Moving on to underlayment. Specifying underlayment for metal siding often comes down to three basic needs. The first is to dry the building in so other work can proceed within the building, and if inclement weather hits, the building envelope is secure. The second is to protect against the chance that moisture will penetrate the metal siding system and act as a secondary moisture barrier. And third is to allow the means of escape for the backside condensation, which may occur in certain metal siding applications. This condensation must be directed out of the system. Siding underlayment is typically required to be semi-impermeable. This means that the underlayment will allow the passage of vapor in one direction, which is from the inside out. The underlayment does not allow for the passage of vapor or condensation into the building. There's a class rating system for siding underlayment, which is climate zone driven, and should be considered before choosing an appropriate underlayment for a specific project. Underlayment class rating system class 1 has less than 0.1 perm, which is vapor impermeable, a vapor barrier. Class 2 vapor barrier is 0.1 to 1.0, which is semi-impermeable. Class 3 is considered vapor permeable and can range from 1 to 10. ASTM E96 determines the perm rating for the underlayment. The appropriate underlayment siding vapor barriers relying upon external and internal siding assembly, cavity, and insulation. The underlayment used for concrete block is different from wood, which is different from a rain screen system. Type 2 or 3 vapor barrier is typically required, giving a vapor perm rating of up to 1.0. The exceptions being coastal environment, refrigerated buildings, indoor pools, amphitheaters, or structures that use non-typical deck or siding materials such as tectum or lightweight concrete. Polyethylene or foil-faced underlayment is acceptable for external applications, but should not be used on the interior as it facilitates molding. Climate zones also need to be taken into consideration as they contribute towards the selection of appropriate perm rating for the underlayment. Photo of a detail. It's a base condition detail. For vertical applications, it's important to note that from a detail and design perspective that the siding base trim is sloped away from the building. The photo with the gray siding shows what a cut panel edge terminated to a J trim at the base of a siding can lead to panel edge corrosion. J trim is used at the base of a siding with it traps moisture and acts as a gutter. This can lead to premature panel deterioration. A siding base trim that is sloped away from the building is critical. Typical parapet cap detail with siding panels installed in a vertical orientation. Notice that there is some slope built into the parapet cap itself to prevent ponding. Also, the exposed exterior of the parapet is concealed, fastened, and attached to a trim cleat. This allows the parapet cap to show no visible fasteners on the exposed side of the cap. Only the interior side of the cap flashing utilized an exposed fastener, and it is not possible to engage both sides of the parapet cap with the cleat attachment. So basically, you have to have screws on one side or the other. These are typical inside and outside corner details which utilize flat trim pieces that cover the factory cut edge of the profile. The trim pieces are typically attached to the high ribs of the panel with blind rivets at 12 inches on center to minimize the appearance of exposed fasteners. Profile closures are installed between the panel and corner trim to prevent wind-driven particulate or pests out of the condition, essentially making for a weather-resistant seal at the corners. Pretty good photo of some inside and outside corner details. This size of corner trim can be adjusted to work with the desired aesthetics of the project. Typical is in the 4-inch by 4-inch or 6-inch to 6-inch range as far as your inside and outside corner trim sizes are concerned. Another option for inside and outside corners are what is known as profiled or mitered corner. This option gives the appearance of the panel cleanly transitioning around the corner. This method is only typically used on horizontal applications. A typical window, door, louvered head condition with a horizontal panel application, a header trim is installed prior to whatever might be installed at this condition. This allows for a proper seal between the header flashing and an opening frame. Just like the base detail, a 1/4-inch gap is needed to allow for weepage between the panel and the header trim. A typical jam condition on a horizontal application also has the trim installed prior to what is being installed in the opening. The panel is then tucked behind the trim and secured with rivets 12-inch on center. Profile closures are used to seal the gaps created by the panel corrugation. Typical sill condition again showed with the trim installed first. The panel is tucked under the siding closure trim and attached with rivets. What is slightly different about this detail is the panel itself. You'll notice the addition of a Z metal behind the panel. This is there and just in case you cannot get a full width panel into the condition because of the layout. The edge of the panel may need to be cut off to fit, and the Z metal is there to support an otherwise unsupported cut panel edge. This is a soffit detail. This unique condition would be a siding panel or fascia panel, the soffit transition. It is handled the same way as a typical base condition with one exception. The cover trim is an adaptation of the base flashing trim with an extra long return to allow for an overlap onto the desired soffit material. Placement of the cover trim should be considered carefully as a sufficient gap will be needed to account for the thickness of the soffit material that is going behind it. Sequencing of this installation would be the soffit material first, then the cover trim, followed by the siding or fascia panels. Siding penetration details can be a bit tricky and truly rely on the skill and the attention to detail by the installing contractor. Typical details are achieved by mounting a flat plate onto the surface of the panels to allow the mounting of various lighting or other mounted fixtures. Most siding penetration mounts need to be field fabricated after the panels are installed to ensure proper placement of the mounting plates. Rib layout often affects the size of the mounting plates that are required. Inlaps for the nestable products are fairly simple to achieve. Panels will lap over one another. This is known as nesting. nestable products that are typically an exposed fastener profile. Concealed fastener profiles cannot typically utilize a nestable inlap due to panel layout and panel profile complexity. These types of overlaps are usually between 3 and 6 inches and sealed within the lap with 2 beads of gunnable non-skinning butyl. Nestable overlaps give a clean, straight lap line and an exposed fasten profile. Unlike nestable profiles, non-nestable profiles require through-fasten trim pieces to achieve panel inlaps. This may work with the desired project aesthetics. Flashing lap lines can be coordinated in a way to match the siding, opening locations, and floor levels on multi-story projects. They work with both horizontal and vertical panel orientation. Vertical trim lap lines shown with horizontal panel application. This is a butt splice with a splice plate installed behind the panel. This would be used on an application where different size and color profiles are going to be located on the same elevation, or where project aesthetics will not allow for a splice trim to be used. Splice lap shown in a unique color mixed project and also on a long siding run. Careful consideration should be taken when selecting this kind of lap. As you will notice, the panel in variations can make the lap lines visible. Vertical panel orientation with horizontal trim lap lines gives a unique appearance, and lap lines can be laid out to match siding openings or floor levels on a multi-story project. That's all I got.
Thank you, Tyler. That's fabulous. We have a bunch of questions here, so I'm going to start working my way through them.
Perfect.
A couple of notes. For those who did post questions, thank you very much. If it gets kind of into the details of a specific project you're working on, I'm not going to ask Tyler to have to weigh in on a specific project, but I'd encourage you to follow up with the technical folks at AEP Span. And there are a couple of themes going on here that you'll catch. One of the things is, one question is asking you to comment on the benefits of a factory applied versus field applied sealant.
Well, obviously, when you have a field applied sealant, you're relying on that contractor to remember to seal every single panel and to do it efficiently. Typically speaking, both are required. With a lot of our siding panels, if factory sealant is installed, then there are some spots where that installing contractor will need to do their own gun grade butyl in some areas. Obviously, labor and cost get taken into consideration as far as the differences between the two. I know that the panels that we offer that come with factory sealant are utilized a lot more. Factory sealant is utilized a lot more than not.
Okay, thank you. This goes back to the installation of the horizontal panels, wall panels that you talked about, and I think it refers to the ones that you install from the bottom up. If a lower panel is damaged, do you have to replace all the panels to fix that lower panel? All the panels from the parapet down?
In some instances, yes, they can. There's a couple things that people can do. You can cut one of the panels and then attempt to put it back together and use a bit of flashing in those areas. But in order to uninstall the bottom panel on one of those runs, yes, absolutely. To do it the 100% correct way, you would need to remove them all.
Okay, thank you. And on those wall panels, what determines whether you're using a vertical stud or a horizontal girt for your fastening position?
It's a design. That's a design consideration as far as building codes are concerned, or it doesn't have anything to do with the metal panel itself. it's what, those engineers are trying to achieve as far as wind loading is concerned.
Okay, thank you. And we're going to take you all the way back to the finishes section at the very beginning. This listener is asking, should we be concerned today about using dark colors like bronze in climates like Pennsylvania where the colors might fade or chalk as they did with systems a few decades ago? Is that an issue now?
It is not. With the new paint systems, I have yet to see a chalk or fade claim come through in the years that I've been working with steel. It's, for whatever reason, they've got the paint systems down to a T, and it just doesn't really happen anymore. Like I said before, and if you've been in the roofing or construction industry for any time at all, absolutely 15 or 20 years ago, a lot of metal panels used to chalk and fade. And if anyone has experience with being on those roofs or siding, even if you ran your hand up against some of that stuff, you would come back with blue chalk or red chalk on your hands. And we just don't see that anymore.
Okay. I got a couple of questions about exposed fasteners and concealed fasteners. How exactly are exposed fastener applications allowing for thermal expansion? How does that, can you describe how that works?
Well, obviously, if you have a fastener at every stud, let's say 12 or 16 inches on center, those panels only expand and contract in between those two areas. And what happens, and it's sort of outlined it in the slide there, it has a tendency over time to expand and contract, and it pulls on those fastener locations. And so over time it will expand and contract so much that it'll waller, the hole will be bigger around those fastening points as time progresses. It takes an awful long time for that to happen, but it does happen, and that's one of the downfalls of an exposed fasten system. Is it's constantly trying to expand and contract against those fastening points.
Yeah. I had a couple of folks here asking, when you were talking about running panels down into a J channel or any kind of panel that you have to cut along the edge, how do you handle the treatment of that cut panel edge?
As long as it's done with a shearing action as opposed to a cutting action, like with a saw or anything that gets that panel hot. If you stay away from that, which is in our install guides, it states real clearly that the panels should not be to be cut in a fashion that makes them hot. Then what happens is that the galvalume or the zinc aluminum has some self-curing properties. So when that panel is cut and that base steel is exposed, that zinc aluminum will self-heal over that exposed steel to keep it from rusting.
Thanks, Tyler. I got another question about fastening parapet caps and nailers in high wind conditions. This person says they use cleats on both sides, but they also use pre-manufacturing parapet caps. Why do you have to have an exposed fastener on the inside? Again, that person wants to understand why that exposed fastener has to be there.
You don't necessarily have to. It aids in the installation of that cap, and it also, if you need to get it off at some point for whatever reason, it's a bit easier to achieve that if you can just remove the screws from the back side. That particular slide, it's not a must-have. It's the way that some manufacturers would rather see it done. Did we get cut off?
Tyler, are you there?
Oh, there we go.
I'm back. I apologize, everybody. I got kicked off of the webinar, and I had to dial back in. But I'm back. Sorry about that.
Okay, I think that I answered that last question.
Okay. Let me see whether I have. And Jack wants to know here on the on your last fill detail whether you offer splice details for that, and I'm not certain what slide number that is. Do you have recall of that? Maybe.
I'm not sure what can you read the question again?
Do you offer splice details in that last? He's curious about the last detail sill detail you talked about. Are there splicing details for that installation?
I'm not sure. I'm going to go back
and
look at the last sill detail that we talked about. It would be slide 62.
Let me take another question while you kind of dig back there. Does AEP span require any shimming of horizontal substructure material to maintain the drainage plane?
We do not. Obviously, you want to have positive slope. We do have some slope considerations depending on, like in a roof application, depending on the slope of that roof system. There are some panels that if it's too flat, then you can't use that panel, or we won't warrant it at that point. But I don't believe that there's any place, especially in siding panels, where shimming is required. We wouldn't require that for a siding issue.
Did you have a chance to get back to that last?
Yeah, I'm looking at it, and I'm not sure what if this question is whether or not we can provide those the actual flashing itself. The answer to that is yes, we can. And if the question is can you lap that piece of flashing, and the answer to that is yes. So
it may be it may be that I butchered that question, so I'll encourage that person to follow up directly with you. What's the maintenance required for the wall panels?
The same as our roofing panels. We suggest that obviously you keep the dirt and debris off of those siding panels. But with siding, especially if it's in a, the wall is vertical, you don't get a lot of debris built up. If you do, one of the maintenance items to wash that panel is just a mild detergent and a soft scrub brush. Other than that, the maintenance for those, besides the obvious things, keeping equipment away and any water runoff is a big one. If you have some water dripping off of something else and dripping onto your metal siding, you need to take into consideration what the water's running off of. We get a big problem with water running off of pressure treated wood onto metal siding, and it creates dissimilar metals because there's copper naphthate in the pressure treated wood. So those are some things that you need to take into consideration.
Okay, great. And I have one final question. Thanks very much. This person wants to talk about the engineered evaluation report for products, and can you talk about how they're important, and does everybody have an engineered evaluation report?
Most metal manufacturers do. If they do not, that might be something that needs to be looked at. I know that we do a lot of our testing in-house, and it's third-party verified. And I would imagine that other metal manufacturers follow suit on that. So the engineering reports, the IAPMOs, and the adherence to the ASTM it's huge, and I would imagine that if some manufacturers didn't have those things, they probably wouldn't be getting spec'd on a lot of work.
Okay, great. I'm not getting to all the questions here, and I would encourage you folks to follow up directly with Tyler or any of the other experts at AEP Span to help you out. And if you had specific application questions, you might talk to your local sales representative who can handle that stuff. But Tyler, thanks very much for a great presentation. If you want more information, go to aepspan.com. Tomorrow at 1 o'clock Eastern Time. 2 o'clock Eastern Time. I said that earlier, longer. 2 o'clock Eastern Time. Look for the follow-up emails with more information about certificates and other follow-ups. Thanks for attending, everybody. Thanks for coming back from last week. We're going to do another webinar on April 16th. Steelscape's going to present on understanding pre-painted metal, so look for information on that. And you can always go to our website for the list of webinars. It's metalarchitecture.com/2020-events. Again, Tyler, thanks very much for a great presentation, and have a great day, everyone.